Hi students, welcome to Brilliant Qatar. In this session, we are discussing the most important 100 MCQ from the chapter Alcohol, Phenols and Ethers, one of the important organic chapter. Let us start from question number 1. Out of the following, this is the 2024 board MCQ question. Out of the following alkene, the one which will produce tertiary butyl alcohol. What is tertiary butyl alcohol? You know the structure. Right, this is our tertiary butyl alcohol. Ready? These all are alkenes. How we can convert alkene to alcohol? That is our first preparation in the chapter. Alkene on acid hydrolysis, we will get alcohol. So which alcohol on acid hydrolysis? What do you mean by acid hydrolysis? Add water in acid medium. So where you will get the tertiary butyl alcohol? Here it's very clear, option D. Let me just show you the reaction. CH3 is the compound, double bond CH2, right? This is the compound D. To which when you add H2O in presence of acid, H2O contain H plus and OH minus ion. What is Markovnikov's rule? We will follow normal Markovnikov's rule. Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. We will get tert-butyl alcohol, right? So option D is the compound which give you tert-butyl alcohol on acid catalyzed hydration. Ready? Question number 2. When phenol react with bromine water, bromine water is a highly brominating agent, right? Strong brominating agent, bromine water. If you use phenol is a very strong ortho-para directing group. Bromine water is ready to give maximum bromine. So what happened? All the bromine goes to all the ortho and para position. You will get 2,4,6-tribromophenol and its color is, just note it all, it's a white precipitate. Phenol on strong bromination, we get 2,4,6-tribromophenol which is a white precipitate. Okay, so you will get a white precipitate here. Moving to question number 3. Which of the following compound is formed when secondary alcohol are oxidized? Primary alcohol on oxidation we get aldehyde. Secondary alcohol on oxidation we get ketone. Secondary alcohol on oxidation we get ketone. Ready? So remember all. Primary alcohol on oxidation we get aldehyde. Secondary alcohol on oxidation we get ketone. What about tertiary alcohol? They do not undergo oxidation. Okay. Next question number 4. Which of the following process does not result in the production of alcohol? Which of the method belongs to the preparation of alcohol? Acid catalyzed hydration of alkene. Just we discussed alkene on acid catalyzed hydration, we get alcohol. Ready? Free radical halogenation, no. B do not give you any alcohol. What is free radical halogenation of alkane to an alkane? When you add halogen in presence of light, that is our substitution reaction. What happened? You will get haloalkane, not alcohol. Reduction of aldehyde. Yes, aldehyde on reduction we get primary alcohol. Hydroboration oxidation. Yes, we studied hydroboration oxidation is a method of preparation of alcohol. So B is the answer. 5. Conversion of trialkyl borane to an alcohol does not require. Do you remember hydroboration oxidation reaction? Let me just to show you that. We have propanol. We have I think we will start from the alkene propene, right? Propene. Hydroboration oxidation is a preparation of alcohol from alkene. This is the one example given in textbook. Take propene and we are treating with a diborane. What is diborane? B2H6. When you treat with a diborane, you will get the compound CH3, CH2, CH2, thrice B. What it's called? Trialkyl borane. This is called hydroboration. Hydrogen and boron addition called hydroboration. Next step, oxidation. Oxidation is done by the help of hydrogen peroxide, base and water. Hydrogen peroxide, base, water. You will get the compound propanol, right? Propanol is the product. So propene to propanol is carried by hydroboration oxidation. Question, which of the following is does not require in the oxidation in the last step. We need water, hydrogen peroxide and base. We don't require diborane. Diborane is required only in the first stage, right? The conversion of trialkyl borane to this alcohol does not require diborane because diborane used in the first reaction. Next one, which of the following alcohol is not polyhydric? What do you mean by polyhydric? Many OH group means more than two. More than two OH group if they contain, they are called a polyhydroxy. So which of the following alcohol is not polyhydroxy? Two or more, that called what? Polyhydroxy. Okay, what is propylene glycol? Propylene means total 3 carbon with, what is glycol? Glycol means 2 OH group on adjacent carbon. What is ethylene glycol? Ethylene glycol means ethylene on which 2 OH group. Ready? What is cyclohexanol? Cyclohexanol is this one. And what is benzene 1,2-diol? Benzene 1,2-diol. Question, which is not a polyhydric. What is the answer? Option C. What do you mean by polyhydrics, dear? They contain 2 or many OH group. These all are polyhydroxy. This is monohydroxy. Next one. Among the following alcohol, which would react fastest with the concentrated HCl and zinc chloride? What is concentrated HCl and zinc chloride? Lucas reagent, right? What is the purpose of Lucas reagent? To distinguish between primary, secondary, tertiary alcohol. See, Lucas test is given by which alcohol faster? Tertiary. Lucas reaction given by tertiary alcohol faster than secondary and primary. Tertiary alcohol give immediate turbidity. Secondary alcohol give turbidity after 5 minutes. Primary alcohol do not give precipitate, only by heat. So question, among the following alcohol, which would react fastest with Lucas mean tertiary. Which is a tertiary alcohol, dear? 2-methyl-butanol. 2-methyl-butanol, right? This is the tertiary alcohol. 2-methyl-butanol is the tertiary alcohol. Yes or no? All right. So pentanol is primary, not that. Pentanol not secondary. So 2-methyl-butanol is the secondary, and therefore it will give the Lucas test faster. Next question. Heating of phenyl methyl ether. What is phenyl? This is what phenyl. This is what methyl and ether. Phenyl methyl ether is nothing but anisole. Okay, is reacting with what? HI, heating with HI. Hydrogen iodide contain H plus and I minus. Do you remember the ether bond breaking, dear? In aromatic ether, what is the condition? In aromatic ether, this is the condition. After breaking, we should get phenoxide ion. What is phenoxide ion? Benzene with O minus. After breaking, so which bond break? We can break it this one. So you get phenoxide and methyl. To the O minus, this H plus get attacked. You will get phenol as one of the product. Plus to the CH3, iodine will attack. You get CH3I. So what is the product? Heating of phenyl and will produces phenol. Yes, phenol is there. Actually, one more product is there, methyl iodide. Question number 9. The alcohol, okay, 8 over, right? Okay, 9. The alcohol which is also known as wood spirit, that is methanol. Wood spirit is what? Dear, there is in one page in your textbook of alcohol phenol chapter they given. Methanol and ethanol industrial preparation. Okay, please carefully study that. Methanol is also called wood spirit, right? Wood spirit because it's produced by the is a byproduct of the wood distillation. Next one, find out the correct order of acidic strength among the following. Phenol, water, ethanol. What is the order? Phenol is more acidic than normal alcohol, and we have water and we have normal alcohol, aliphatic alcohol, ethanol. Why phenol is more acidic, dear? When it lose this H plus ion, it giving more stable phenoxide ion. Therefore, phenol is more acidic. And water, water contain HOH, right? And ethanol means what? C2H5OH. The main factor affecting acidity, EWG. EWG if there, electron withdrawing group if there, that make the compound more acidic. Electron donating group decrease the acidity. Alkyl groups are plus I effect. They are EDG. EDG decrease the acidity. Therefore, ethanol least, then water, then phenol. So correct order dear, phenol greatest, okay? Correct order phenol, water and ethanol, option B. Question number 11. Which of the following reagent may be used to distinguish between phenol and benzoic acid? Dear, phenol, if they mention in distinguishing test, then there is a very special name reaction is there which you may did in the practical also. That is our neutral ferric chloride test. What happened when phenol react with a neutral ferric chloride? Neutral ferric chloride, hydrogen combined with Cl, HCl goes, iron combined with the phenoxide, Fe combined with the phenoxide ion 6 times and 3 minus. It form a complex having violet color. This is a clear cut a distinguishing test of which one phenol. Phenol when react with a neutral ferric chloride, you will get a violet colored complex. This is only given by phenol compounds. So phenol one. So neutral ferric chloride is the best reagent to distinguish between phenol and acid because acid do not respond this test. Next question number 12. Rate of dehydration of alcohol. Dear, dehydration is elimination, right? Removal of water, right? Elimination mainly follow which mechanism? That's SN1, stability of carbocation. General, okay, general. Beta elimination, dehydration. These all reaction follow SN1 mechanism. You know SN1 mechanism, what is the order? Tertiary, secondary, primary, right? So tertiary, secondary, primary, then methanol, option B. Question 13. Phenol on heating with a phenol on heating with a chloroform and NaOH gives salicyl aldehyde. Yes, we know salicyl aldehyde. What is the complete reaction actually? First you will get sodium phenoxide and CHCl2. This again we react with NaOH and this one acid. We will get which one? Salicyl aldehyde. What is salicyl aldehyde? OH and CHO. What is salicyl aldehyde preparation is called known as Reamer-Tiemann reaction. If it is salicylic acid, what you call? Kolb's reaction. Next one, 14. Which of the following is a secondary alcohol? Option A, 2-methyl-butan-2-ol. 2-methyl-butan-2-ol. Here it's tertiary, right? Because OH connected carbon connected to 3 carbon. It's tertiary. Option B, 3-methyl-butan-2-ol. 3-methyl-butan-1-ol. Here this OH connected carbon only connected to 1 carbon. It is primary, not that. 2-methyl-butan-1-ol. 2-methyl-butan-1-ol. Again this OH connected carbon connected to 1 carbon. It's primary. 3-methyl-butan-2-ol. 3-methyl-butan-2-ol. Yes, the OH connected carbon connected to 2 carbon. Yes, it is secondary. That is option D. So how you judge it? Primary, secondary, tertiary? The OH connected carbon directly connected to how many carbon? If the OH connected carbon connected to 1 carbon, it's primary. 2 carbon, secondary. 3 carbon, tertiary. Next one. When salicylic acid is heated, what is salicylic acid here? Salicylic acid is alcohol and acid in the adjacent position. That's called a salicylic acid. Is heated with a zinc dust. What is the main product? Do you remember? Phenol when treated with the zinc, it become benzene. Because Zn take this oxygen out, ZnO eliminate. So what is left? Benzene with the COOH. What is benzene with the COOH? Benzoic acid. You know, phenol when react with, okay, phenol, we studied this reaction here. Phenol when react with the zinc dust, it become benzene. Yes, that's what happened. But acid remain the same. Ready. Next one. What is the general formula of an aliphatic alcohol? What are aliphatic alcohol? We can write ROH, right? Aliphatic alcohol means there is an aliphatic alkyl group and alcohol OH group. Next one, which of the following is true regarding polyhydric alcohol? What do you mean by polyhydric alcohol? They contain OH group, 2 or many. So it should have 1 or more, no? It should have 2 or more OH group. They are called what? Polyhydric alcohol. Which of the following type of alcohol contain a bond between sp2 hybridized carbon and OH group? Can you say dear? See, that is very clear. You may study it in haloalkane chapter also. Vinylic. What is a vinyl group? CH2 double bond CH. This is called vinyl with alcohol. Now you see the alcohol connected to which carbon? sp2, sp2, right? sp2 carbons are there. So which of the following type of alcohol contain a bond between sp2 hybridized carbon and OH, right? sp2 hybridized carbon is on vinylic, option D. Which of the following term does not describe this compound? Is it a primary alcohol? Yes, because the OH connected carbon connected to one carbon, it's primary. Is it monohydric? Yes, because it contains only one OH group. Is it allylic or vinylic? Check it all. The alcohol connected carbon, this is what? sp3, this is what? sp2, this is what? sp2. Can you say what is this pattern? sp3, sp2, sp2 is allylic, right? It's an allylic alcohol. It's not a vinylic. What is meant by vinylic? The alcohol connected is sp2, again sp2. What is allylic? sp3, sp2, sp2. Ready? Next one. Choose the most suitable classification of the shown compound. Most suitable classification. Is it a secondary alcohol? No, because the OH connected carbon connected to 3 carbon it is tertiary. Is it allylic? Let me check. OH connected carbon, this is what? sp3, this is what? sp2, this is again sp2. Yes, this is what? Allylic, correct? Allylic alcohol. Is it dihydric? No, it's monohydric because it contains only one OH, not benzylic. Ready? Next one, choose which of the following is not a vinylic. Not a vinylic. What is meant by vinylic alcohol? The alcohol connected to sp2, again sp2. That is called vinylic. So here OH connected is what? sp2. How to check it sp2? Double bond connection is there or not? There sp2. So sp2, sp2. Yes, it's vinylic. Here alcohol connected to what? sp2, sp2. Yes, vinylic. Here alcohol connected to sp3, sp2, sp2. No, this is not vinylic. What about this OH connected to sp2, sp2, vinylic. So option C is not vinylic, it is allylic. Right. Next one. Which of the following is not an aromatic ether? Means aromatic means what? Benzene should be there. Right. What is the first compound? C6H5 means what? Phenyl. So OCH3. Yes, it's an aromatic ether. Option B, dear. What is option B? CH3, OCH2, CH3. Is it contain any aromatic? This is both are aliphatic, right? So this contain phenyl, phenyl, phenyl. Phenyl means what? Benzene, aromatic. Next one. What is the correct order of acidity of alcohol? Which alcohol is more acidic? Let me take it a primary alcohol. Let me take a secondary alcohol and let me take a tertiary alcohol, right? Tertiary alcohol. Which alcohol is more acidic? Can you say, dear? What is the difference between primary, secondary, tertiary alcohol? The number of alkyl group. Only one alkyl group, two alkyl group, three alkyl group. You know, alkyl groups are EDG plus I effect. Alkyl groups are electron donating group. They will decrease the acidity. So where more alkyl group, where less acidity. So what is the order? Primary greater than, secondary greater than, tertiary is the order of acidity. Question 24. What is the IUPAC name of salicylic acid? What is salicylic acid? Salicylic acid means OH and COOH on adjacent. Here which is the main functional group? Acid. So this is 1, this is 2. So what is the name? 2-hydroxybenzoic acid. 2-hydroxybenzoic acid, option 3. Next one, which of the following alcohol produce turbidity immediately when react with the Lucas? Lucas reagent turbidity given by tertiary alcohol faster. Which is a tertiary alcohol? No doubt, tert-butyl. You know what is tert-butyl? This group is called tert-butyl alcohol. Ready? When reacted with this one. Which compound results in the formation of the most stable carbocation on dehydration? We said that dehydration follow SN1 mechanism. Stability of carbocation is the factor. Let me check it. Option A. Option A is what? CH3 thrice and OH. What is the first step in dehydration? The OH leave, you will get a carbocation. See all, it is a tertiary carbocation. So this will undergo reaction. faster. So what is the stability order of, what is the reactivity order of dehydration? Tertiary greater than, secondary greater than primary. Ready? So tertiary will undergo reaction faster. On treatment with the excess bromine water, phenol give, we discussed that phenol when treated with the bromine water, it will give you 2,4,6 tribromophenol white precipitate. 2,4,6 tribromo, right? There is a 2,4, yeah, that's all. 2,4,6 tribromophenol. Don't forget the color, white precipitate. Next, the reagent used for converting ethanol. What is ethanol? C2H5OH to what? Acetic acid, CH3COH. Dear, a primary alcohol, if you want to directly convert into acid, we need a strong oxidizing agent. What is a strong oxidizing agent here? Acidified potassium permanganate, KMNO4. Acidified KMNO4 is the strongest oxidizing agent. It will give you a primary alcohol directly to what? Acid. Now, the reagent used for the formation of 1-phenyl ethanol. What is that 1-phenyl ethanol? Eth means 2 carbon, 1-phenyl ethanol, right? This is the compound, okay? 1-phenyl ethanol. If you want to get this compound from benzaldehyde, what is benzaldehyde? Benzene with what? CHO. What is the reagent? Here, benzaldehyde on benzene 1 carbon. But in the product, there are 2 carbons. So we need to increase 1 carbon extra, mean bring the Grignard reagent. What is the Grignard reagent here? Methyl bromide. Yeah, this one. Methyl bromide and magnesium. What is methyl bromide? CH3Br. What happened that react with the Mg? You will get CH3MgBr. That is our Grignard reagent. So take our Grignard reagent, all, Grignard reagent CH3MgBr. What are the ion? Mg plus and CH3 minus. So this will at nucleophile attack on this. O become O minus. To the O minus MgBr we will attack. You will get CH O minus MgBr and here CH3 attack. What is the last step? Acid hydrolysis. Add water in presence of acid. What are the ions in water? H plus and OH minus. So H plus go to this O minus, OH minus go to this Mg. You get CH benzene, CH, CH3, OH. So answer is which one? Option 4. So if you want to increase 1 carbon in aldehydes and ketone, mostly Grignard reagent is the attacking one. Next one, methyl alcohol react with, what is methyl alcohol? CH3OH. Methyl alcohol react with sulfuric acid at 4, sulfuric acid H2SO4 at 413 Kelvin. Please remember dear, 413 Kelvin. We know alcohol when heated with the acid at 443 Kelvin, it undergo dehydration. But at 413 Kelvin, it forms ether. If you use methanol, it will give the ether, that is methoxymethane. Methoxymethane. If you use ethanol, you will get ethoxyethane like that. Okay. So careful. Alcohol when heated with the acid at 443 Kelvin, dehydration. At 413 Kelvin, ether formation. Next one. Which of the following has the highest boiling point? Highest boiling point. Propanol, it's an alcohol. Propane is a hydrocarbon. Methoxyethane is an ether. And N-butane is again hydrocarbon. See, mainly the one which is depend on the boiling point is what? Mass and the hydrogen bonding. Which one make more hydrogen bonding in this one? Alcohol make more hydrogen bonding. You may study the general order of the boiling point here. Just note it all. The boiling point order is mainly one. Main boiling point is for carboxylic acid, then alcohol, then aldehydes and ketone, approximately same one, then ether, and then we have hydrocarbon, that is mean alkane and alkene and all. Okay, so main functional group, these are the just a priority order of their acidity. Alcohol is the highest acidic among this one, option A. 32. What is the order of the acidity? Dear, remember this point carefully. Electron withdrawing group increase acidity, electron donating group decrease acidity. Remember that point, okay? Chlorine is an electron withdrawing group. You know, chlorine is a slight donating and withdrawing in this benzene. And alkyl groups are pure EDG. Nitro is a very strong EWG. and methoxy group also a strong donating group. So who make more acidity? Withdrawing groups, right? Which is the most withdrawing group? Nitro, then chlorine. Okay, among nitro and chlorine, nitro is the more withdrawing, so it make more acidity. So third one greatest, then first one. Third one, first one, right? And what about this 4 and 3? Methyl and methoxy, when you consider, methoxy is more donating. More donating means least acidic. Okay, therefore fourth one is least. Ready? Next one. The final product formed when benzyl ethyl ether. What is benzyl group? Benzene with an sp3 carbon. This is called benzyl. Benzyl ethyl, okay, benzyl ethyl ether react with the hydrogen iodide. Okay, hydrogen iodide. This is also our ether bond breaking. Remember, we have H plus and I minus. Where which bond you can break, whether the left one or the right one. Which will you break? I am going to break the left one. If you break the left one, oxygen always get negative, carbon get positive. What is this group is called? Benzyl. Benzyl carbocation is highly stable due to resonance. So break this bond here if you have benzyl group. So to the plus, the minus comes. So what is comes here? To the benzyl iodine attack. What do you get? Benzyl iodide. Benzyl iodide. Benzyl iodide. What is the other one? To the O minus, this H will attack. So what do you get? C2H5OH, ethanol. Benzyl iodide and ethanol get formed. 34. The major product formed when anisole. What is anisole? Benzene with OCH3. Anisole when react with the bromine in ethanoic acid. It's bromination. Anisole is a ortho para directing group. So what you get? Ortho bromo anisole and you get ortho bromo anisole and para bromo anisole. Okay, ortho bromo and para bromo. You know, in among ortho and para bromo anisole, which is the main group, para is the majorest one. So the major product will be para bromo anisole, option A. 35. Formaldehyde react with grignard. Remember dear, what is formaldehyde? HCHO. Formaldehyde when react with the grignard reagent, you will get always primary alcohol. The other aldehydes when react with the grignard, that means other than methanol or formaldehyde, ethanol, propanol, other aldehyde when we use, always you will get secondary alcohol, and any ketone when react with the grignard reagent, you will get tertiary alcohol. Please remember, okay? So formaldehyde when react with the grignard reagent, we will get primary alcohol. 36. Phenol can be obtained by dash of sodium phenoxide. What is sodium phenoxide? Sodium phenoxide is ONA. To which what we will add actually? HCl. So Na and Cl cut. Yes, we will get phenol. So what is HCl addition process we call? Acidification. Sodium phenoxide on acidification we get phenol. 37. Cumene hydroperoxide. Hope you remember the cumene preparation. What is cumene? Cumene is a isopropyl group. A isopropyl group on benzene is called cumene. First, when react with the oxygen, what we will get? The oxygen get added in between this C. You will get OOH. OOH. And the CH3. What do you call this compound? Cumene hydroperoxide. This on acid hydrolysis, we get the product as what? Phenol and acetone, right? Propanol. These are the byproduct. Phenol is the main one, acetone is the byproduct. So cumene hydroperoxide is this one. On treated with acid, what you get? You get phenol and acetone. 38. Identify the compound X. Where is X in this compound here? This simple reaction. How you convert benzene to, what is this benzene with the SO3H is called? Benzene sulfonic acid. How you convert benzene to benzene sulfonic acid? Treated with a fuming H2SO4 called what? Oleum. Fuming H2SO4, what you call? Oleum. So benzene treated with oleum, we get benzene sulfonic acid. Next one, which of the following is the least soluble in water? Least soluble in water. See, all are alcohol, right? All are alcohol. You know, alcohols are highly soluble in water because they can form very strong intermolecular hydrogen bond with the water. But all are alcohol, which one is less soluble? What is the condition? Butyl, pentyl, hexyl, heptyl. As the number of carbon increases, the solubility decreases. So which one having greatest carbon? N-heptyl, so solubility lesser. Question number 40. Which of the following has the highest boiling point? Highest boiling point. Here again, all are alcohol. Alcohols have high boiling point due to strong intermolecular hydrogen bond. So, and you check where branches increases, boiling point decreases. Mass increases, boiling point increases. So, proper, we can cut it. Anyway, very simple. Proper butapent. Pent having the greatest number of carbon. As the number of carbon increases, boiling point increases. Next one. Monochlorination. Monochlorination means one chlorine we are adding of toluene. Alright. So let me toluene. What is toluene? Benzene with a CH3. Toluene when undergo chlorination in presence of light. What happened? Chlorine goes to, substitution. Substitution means chlorine goes to this position, right? You will get benzene with a CH2Cl. What you call this compound here? Benzyl chloride. Ready? Followed by hydrolysis with aqueous NaOH. What happens if you treat it with aqueous NaOH or aqueous KOH? The NaCl out, OH group comes, you will get benzyl. This group is called benzyl, okay? OH comes. What is the product here? Benzyl alcohol is the product, option 4. 42. How many alcohol with the molecular formula C4H10OR? Chiral in nature. You know what is chiral? The carbon, all 4 bonds are connected to 4 different groups or atoms. Let me write the possible structure of the compound faster, okay? Total 4 carbon, right? Okay, we can write butane 1-ol. Okay, next we can write butane 2-ol. Yes, butane 2-ol. Next, now let me change the position of the alkyl group. I can write this another alcohol and I can write a tert-butyl alcohol also. So these are the possible structure of which one? This alcohol with the 4 carbon. Here, how many of them are chiral? I will say there is only one. Only one is chiral. Which one? The second one. You see, this carbon, you check it all. This carbon is chiral. Because this carbon connected to OH group, H, methyl and ethyl. See, all 4 are different. You check other group, there is no chiral carbon in this one. So among these 4, there is only one is chiral in nature. 43. What is the correct order of the reactivity of alcohol in this reaction? What is HCl and ZnCl2? Lucas reagent. Lucas reaction follows the order tertiary greater than secondary greater than primary. Tertiary will give immediate turbidity because it follow SN1 mechanism. So tertiary, secondary, primary, option 3. This is what? Ethanol. Ethanol can be converted into ethanol. A primary alcohol, if you want to convert into aldehyde, we have many reagents, PCC, anhydrous CrO3, copper at 573. Which is the best reagent to convert a primary alcohol to aldehyde? PCC, that is our pyridinium chlorochromate. Best reagent to convert a primary alcohol to aldehyde is PCC. 45. The process of converting alkyl halide. What is alkyl halide? For example, RCl. Into alcohol, what is that? ROH is called, which reaction? Removal of chlorine, substitution of OH group. What do you call that? Nucleophilic substitution. Nucleophilic substitution, right? You studied in haloalkane chapter. Removal of halogen, bringing OH group. What is that called? Nucleophilic substitution. We are treating with the aqueous KOH and all right. Next, 46. What is the IUPAC? Simple question. Here, chlorine is there, OH is there. Which is the main functional group? OH. So this is 1, 2, 3, 4, 5, 6. 5-chloro. What is the answer? Option 3. 5-chlorohexane-2-ol. Ready? Simple. Question number 47. What is the IUPAC name of metacresol? What do you mean by cresol, dear? Cresol mean phenol with a methyl group. Phenol with a methyl group is called cresol. Meta means we place it in the meta position. So 1, 2, 3. 3-methyl phenol. 3-methyl phenol. So we have 3 compounds like this one: orthocresol, metacresol, paracresol. Change the position, okay? And what is the IUPAC name of this ether? Ether is given as CH3, CH and CH3, then OCH3. How to name this ether? See the ether left and right. Where is the biggest chain? Left. So select the parent 1, 2, 3. So this is the branch methoxy. Where the methoxy presents second position. So 2-methoxypropane. 2-methoxypropane is the compound, right? 2-methoxypropane. Next, which of the following compound will react with the sodium hydroxide solution in water? Dear all, sodium hydroxide is a base. So what they're asking actually, which is more acidic? The one which is reacting more with the sodium hydroxide, that indicating which is more acidic, okay? So which of the following compound will react with the sodium hydroxide solution in water faster, right? Which of the following compound will react with the sodium hydroxide solution in water faster, okay? That's actual question. Which is more acidic here? This is aliphatic alcohol, aliphatic alcohol, aliphatic alcohol. This one is phenol, dear. We know phenol is more acidic because when it loses this H plus ion, it forms phenoxide ion. Okay, remaining all OH is connected to the alkyl group. Alkyl alcohols are very least acidic than which one? Phenol. Next one, phenol is less acidic than. Phenol is less acidic than which compound? Can you say, dear? Phenol is less acidic, or from the option which is more acidic. I will go with this nitro, because nitro is a electron withdrawing group. You know, electron withdrawing group make the compound more acidic, right? So nitro, ortho, nitro, phenol. You know, methyl and methoxy all are EDGs. They will decrease the acidity. Next, which of the following is most acidic in nature? I will just draw the structure. First one is benzyl alcohol, all right, benzyl alcohol. Second one is cyclohexanol, all right. Third one is phenol, all right. Next one is metachloro. Fourth one is metachlorophenol. Which is more acidic, dear student? Dear, tell me. This is like aliphatic. OH is not on benzene. OH, this is not benzene. This is, yes, this is highly acidic. It's also, phenol is more acidic than normal alcohols, right? Aliphatic alcohol. So what about with the among D, third and fourth, which one? Chlorine is an EWG. EWG, electron withdrawing group, make more acidity. So let's go with the fourth option. Question number 52. Mark the correct order of decreasing acid strength. Let us see here. All are phenol, all are acidic, right? Nitro is an EWG, methoxy is EDG, nitro is EWG, methoxy is EDG. You know, withdrawing group make more acidic. So B and D are more acidic. Among B and D, which is more acidic? I will go with the para instead of meta, because para position, whatever the group present, that effect will be more. If para position nitro group present, its withdrawing effect will be more. So para having greatest, therefore B greatest than D. So option 2. BD, after that without any EDG, this one, and then B and E, when you check it, what you can say? I told you para position, if any group comes, its effect will be more. Here you see methoxy, the electron donating group is in para. So in para effect, that para position, if methoxy present, its donating effect will be more. Donating effect will be more. So this one more donating, therefore least acidic here. Ready? Question number 53. Arrange the following compound in increasing order of boiling point. Boiling point mainly depend on two factors here. One is mass. Greater the mass, greater the boiling point. Second one, functional group and branching. So here all are alcohol, right? Propanol, butane 2-ol, butane 1-ol, pentanol. See, propanol mean 3 carbon with OH. Butane 2-ol mean 4 carbon with second position OH. Butane 1-ol means 4 carbon OH. And pentane 1-ol mean 5 carbon with OH. Which one having greatest mass? Pentane 1-ol. So greatest. Among butane 2-ol and butane 1-ol, which one having greatest boiling point? Butane 1-ol, because there is a branch in butane 2-ol. Branches comes, what happen? Boiling point decreases. And this one. So which is the correct increasing order? Like, I think it's option A. Pentane 1-ol is the highest, then butane 1-ol, then butane 2-ol, then with less carbon, propane 1-ol. 54. The carbon, oxygen, hydrogen bond. Please remember all. In alcohol, what is alcohol general formula? For example, let me take methanol. CH3OH, right? CH3OH. You know, oxygen contain 2 lone pair. Let me take an ether, methoxymethane. What is methoxymethane? CH3OCH3. There is a lone pair. Ready. You know what is normal tetrahedral structure? Let me take it for example, methane. Tetrahedral bond angle is 109.5 degree. Okay. Tetrahedral bond angle is 109.5 degree. Question. The carbon, oxygen, hydrogen bond angle in alcohol is slightly less than the tetrahedral bond angle. You know what is the reason? The lone pair repulsion in the alcohol. Lone pair repulsion is more. So this bond come close. So in alcohol, the bond angle is less than tetrahedral. Correct. They already mentioned that. Whereas, why the carbon oxygen carbon bond angle in ether is slightly greater than this tetrahedral? You know, it's around 110 degree. Why in ether the bond angle is greater than this tetrahedral? Because of the bulky group. The bulky group, when do not come closer, they will repel. So bond angle increases. So what is the answer? Option A of the repulsion between the two bulky groups. So remember all. In alcohol, why the bond angle is lesser? Because of lone pair repulsion. In ether, what is the bond angle greater? Because of the bulky group repulsion. Ready? Next one. An alkene is already we discussed here. What is this alkene? Propene. Propene when treated with what is this? Diborane. You will get trialkyl borane. That's on hydroboration over. Next oxidation we will do it. Propene become propanol. We did already this question, so I'm just writing the answer here. Propanol. Next, choose the correct X and Y from this one. Choose the correct X and Y. What you understood from the first figure here, NaBH4. Come on, what is NaBH4? It is a reducing agent. It converts aldehyde to primary alcohol, ketone to secondary alcohol. So dear, this is a ketone. No doubt, ketone becomes secondary alcohol. So that become OH. What is this? It's not an ether, dear. This is RCOOR. It is an ester. Ester do not disturb by NaBH4. Don't touch it. Okay. So ester remain as it is CH2COOCH. This is the first product. Okay. Here also NaBH4. NaBH4 will reduce ketone to secondary alcohol and aldehyde to primary. Can you see there is an aldehyde group? Yes, that become alcohol. So what is the product? CH3, CH2, CH3 and CHO become CH2OH. Check where these changes are present. So OH, CH2, CO, CH3, CH2, CH2, right? Option C, dear. See, OH, then the ester is remain as it is and finally becomes CH2OH. Question number 57. 1 mole of ethyl acetate. What is ethyl acetate? You know, this is acetate, CH3, COO, C2H5. This is called ethyl acetate. Ester. Ester when react with the excess of LiAlH4. You know, what happened? You know, what is LiAlH4? Reducing agent. Ester when reduce, you will get 2 alcohol. How we get 2 alcohol? Very simple, dear. Just to cut the CO bond, only to understanding, okay? Ester and react with the LiAlH4, that bond break. Which bond? CO bond just to break. How many carbon left side? 2 carbon. 2 carbon alcohol is what? Ethanol plus. How many carbon right side? 2 carbon. Again you will get ethanol or ethyl alcohol. So you will get 2 ethanol molecule. So what is that? 2 moles of ethyl alcohol. So ester on reduction we get 2 alcohols. Next one. Tertiary butyl alcohol can be prepared by tertiary butyl alcohol. What is tertiary butyl alcohol? This is the tertiary butyl alcohol, right? It's a tertiary alcohol. I told you that if you want to get a tertiary alcohol, you should take a ketone with what? Grignard reagent. Ketone when react with the Grignard reagent, you will get tertiary alcohol. So aldehyde, no. Acetone and methyl. What is acetone, dear? Acetone is propanone. Yes, acetone is propanone plus what? Methyl magnesium iodide. Yes, that is our Grignard reagent. So formaldehyde will give primary alcohol we discussed, and even this also possible, right? Butanone, it's a ketone and a Grignard reagent. So option B or D, how to judge it? See, acetone contain 3 carbon and the methyl magnesium contain 1 carbon. So total 4 carbon. Yes, we need 4 carbon. So answer is option B. Why not option D? Butanone already contained 4 carbon and methyl magnesium, the Grignard reagent 1 carbon. So your compound should contain 5 carbon. No, we need only 4 carbon, right? So that is what B. So remember, ketone when react with the Grignard reagent, we get tertiary alcohol. Now, In the following sequence, what is the final product Q? What is happen? Benzene react with the oleum. Benzene when react with the oleum. What is oleum? Fuming H2SO4. We get benzene sulfonic acid. Benzene sulfonic acid first react with the NaOH. Second, on acidification, you will get phenol. It's a preparation of phenol from benzene. So compound is what? Phenol. Dear, in the textbook, you studied 4 preparation of phenol, right? One is from benzene, one is from aniline, one is from cumene and all, right? So those kind of reaction, and those process chlorobenzene also there. Next one, 60. Cumene on reaction with the oxygen followed by, we already discussed cumene on reaction with the oxygen. First you will get cumene hydroperoxide. That's on acid hydrolysis. You will get phenol and acetone. What is the product? Phenol and acetone. Where is phenol and acetone, dear? Phenol, C6H5OH is phenol, CH3COC, right? Anisole. Sorry, phenol and acetone. Which of the following reaction will not yield phenol? I just told you there are 4 preparation of phenol in textbook, which is not a preparation of phenol. Come on, dear. Chlorobenzene. How you convert chlorobenzene to phenol? Dose process. What is dose process? First aqueous NaOH, then at 623 Kelvin and 300 atm pressure, then followed by acid hydrolysis. Correct? Yes, you will get phenol here. Aniline, first diazotization, then warm water. Yes, we get phenol. Benzene, oleum, NaOH, H+. Yes, just we discussed. This is again dose process, but you see here dose process means chlorobenzene starting with what? Aqueous NaOH at 623 Kelvin and 300 atm. They used 100 atm, 298 Kelvin. No, it won't give you phenol. Question number 62. Orthonitrophenol. You know what is orthonitrophenol? What is orthonitrophenol, dear? Orthonitrophenol. This is orthonitrophenol. We studied that there is a intramolecular hydrogen bond, which is a weak hydrogen bond. What about paranitrophenol? That's having intermolecular hydrogen bond, which is strong hydrogen bond. Question: why orthonitrophenol is less soluble in water than meta and para? Orthonitrophenol having intramolecular hydrogen bond, which is a weak bond. Weaker the hydrogen bond, lesser the boiling point. So orthonitrophenol shows intramolecular hydrogen bonding. Yes. Next, for the reaction, this is what ethanol with the hydrogen halide, you will get alcohol when react with the hydrogen halide, you will get haloalkane. What is the order of reactivity? Many times we are discussing that. If you consider HF, HCl, HBr, HI, which one is more reactive here? HI, because down the group size of the halogen increases. When size of the halogen increases, the bond become weak, easy to break, easy to undergo reaction. So HI, HBr, HCl, right? Option B. Which of the following is the proper method to prepare N-hexane from N-propyl alcohol? No, N-propyl alcohol, that's propene, okay? Not N-propyl alcohol. Propene, right? Propene. So what is propene, dear? Propene is which one? This one. So propene, how you can convert it into hexane? So 3 carbon is there, product contain hexane, double mean Woods reaction. Okay, so let me bring one bromine on the second position. So what we can add here? HBr in presence of what? Peroxide. Let me first convert into a haloalkane. According to Andy Markonikov's rule, negative part goes here, positive part goes here. You will get CH3, CH2, CH2Br. Right? Next we have treated with the word sodium and dry ether. The alkyl group double. This is propyl. Yes, it converted to what? Hexane. So which is the best reagent to convert propene to hexane? That is HBr peroxide and sodium and dry ether. If you want to double the number of carbon, what is the reaction? Woods reaction in this chapter. Now arrange the following alcohol in the order of increasing reactivity toward sodium metal. So I told you, sodium metal, sodium hydroxide, these all indicating what? Which is more acidic. The one which is reacting sodium faster, sodium hydroxide faster, all indicating what? Which is more acidic. Dear, this is a tertiary alcohol, right? Just expanding. Is it? Tell me fast. Is it a tertiary alcohol? Yes, it is tertiary. This is secondary. This is primary. What is they're asking? Arrange the follow. Which is more acidic? You know which is the acidity order of alcohol? Primary greater than, secondary greater than, tertiary. So third one is having the highest, then second one, then first one. Third, second, first, option C. Dear, the one which is reacting with the sodium faster, sodium hydroxide faster, indicating what? Which is more acidic. Don't forget, okay? So which is more acidic here? Primary. Next one. Out of 2-chloroethanol, let me draw the structure of 2-chloroethanol, right? 2-chloroethanol, all right? 2-chloroethanol and ethanol, all right? Which is more acidic and why? I will go with this one. Because chlorine is an EWG. EWG make the compound what? More acidic. What is that EWG effect is called? Minus I effect. So 2-chloroethanol is more acidic due to plus I effect. No. 2-chloroethanol is more acidic due to minus I effect of chlorine. Yes. 67. What is the correct order of the strength of the acidity? Come on dear. All are alcohol. So check. Alkyl groups are EDG. Nitro group is EWG. There are 2 nitro group EWG. You know EWG make more acidic. Here more EWG, more acidic. So fourth one is the highest, then third one, then first one, then last with the EDG. So fourth greatest, then third one, then first one, right? Option D, right? Fourth is the highest because it contains more withdrawing group. Then third one, only one withdrawing. Then first one, and why the second one is very least? Because it having EDG. EDG bring the acidity down. Next one, para-nitrophenol is stronger acid than phenol. Para-nitrophenol. Dear, this is phenol, para position nitro. They are saying this is more acidic than which one? Phenol, all right. And while para-cresol is weaker acidic than which one? What do you mean by para-cresol? Para-cresol means phenol with the CH3, okay? OH and CH3 together is called cresol. So why this is the nitro group one which contain is more acidic than phenol? Nitro is an electron withdrawing group or minus I effect group. How they make more acidic? Now, electron withdrawing group means they will withdraw the electron from the chain and they will reduce the electron density on the OH bond. They will reduce the electron density on OH bond, so you can lose the hydrogen faster. Ready all? So nitro group is an electron withdrawing. When electron withdrawing group withdraw the electron from the OH bond, the OH bond get weaker. So you can easily give H plus, it become more acidic. What about if there is an EDG present? EDG when present, they will give electrons to OH, make the electron density on OH bond greater and the bond becomes stronger. If it is stronger, can you remove H plus? No. So what is the answer here? CH3 group decreases the electron. No. Electron donating group increase, okay? Nitro group decrease the electron density on oxygen hydrogen bond, making para-nitrophenol stronger acid. Ready? Question 69. An unknown alcohol is treated with a Lucas reagent to determine whether alcohol is primary, secondary, tertiary, all right. Which alcohol react fastest and by what mechanism? Which alcohol give immediate turbidity? Tertiary alcohol, right? Tertiary alcohol will give immediate turbidity by through SN1 mechanism. Tertiary alcohol by SN1 mechanism. Now consider the following reaction sequence. Okay, let me just take the compound one by one. CH3, CHOH and CH3. They are reacting with a concentrated acid and heat. What happened? Alcohol heated with an acid? Dehydration. What is dehydration? OH and H. Water take it, a double bond, you will get it. You will get an alkene, propene. Ready. So this is the compound X. This propene to which they are adding dilute acid in present, dilute acid and water, right? Water. What is this process called? Acid hydrolysis. You know, H2O contain H plus and OH minus. It follow Marconi-Co's rule. Negative part goes here, positive part goes here. You will get propan to all the compound back. So this is Y. So question, what is the X? What is this for two product? So one is propene. I think it's option A, right? One is propene. Then what is that last one? Propan to all. Ready? Next one. The most suitable reagent for the conversion. Already we discussed that. It's a primary alcohol to aldehyde. Come on dear, which is the best? The best reagent to convert a primary alcohol to aldehyde is which one? PCC. Next, the vapors of an alcohol X when passed over hot reduced copper produce an alkene. The alcohol is, copper at 573. You may study that it is an oxidizing agent, right? Mild oxidizing agent. That they said here. I told you primary alcohol on oxidation we get aldehyde. Secondary alcohol on oxidation we get ketone. Tertiary alcohol do not undergo oxidation. Instead it undergo dehydration. For example, let me take a tertiary alcohol, okay? It is our tert-butyl alcohol. The tert-butyl alcohol when treated with copper at 573 Kelvin here. It's an oxidizing agent, but tertiary alcohol do not undergo oxidation. Instead it undergo dehydration. So OH, water cut, you will get the alkene. So which alcohol give you a alkene with copper at 573? That is tertiary alcohol. One more question based on this one. What happens when tertiary butyl alcohol? This is the tertiary butyl alcohol, okay? At 300, what is 300 degrees Celsius in Kelvin? 573. Okay, or over copper. So that they are asking the same reaction. What is this product here? This is 1, 2, 3. 2-methyl propene. Same question they are asking. 2-methyl propene is the answer. 2-methyl propene is formed. So remember, tertiary alcohol do not undergo oxidation. Instead it undergo dehydration, forms alkene. 74. Which of the following compound will be most easily attacked by an electrophile? Their electrophile charge is plus. Electrophile charge is plus. So where plus charge species attack? Negative, right? Alcohol is EDG. Alkyl groups are EDG. Halogens on benzene ring have EDG and EWG effect. EDG, whenever you studied you just check the phenol resonance structure. Phenol resonance structure, if you check the ortho and para positions get negative charge. Whenever there is an EDG group on benzene ring, if you draw the resonance structure, all the ortho para position you get negative charge. That means electron rich. So electron donating group make their ortho para electron rich. So electrophile can easily go to which place? Ortho and para. So whether option C or D, both are EDG. EDG when present, electrophile can easily go to ortho and para. Among alcohol and methyl, which is more donating? Alcohol, because it's having lone pair. So option C. So electron donating groups make the ortho para position always electron rich. So electrophile can easily attack. Next, out of benzene, ready, let me take the compound, out of benzene and phenol, out of benzene and phenol. Why phenol is more easily nitrated? What do you mean by nitration? Nitration means bringing NO2 electrophile. Again, same question, what we said, why electrophile can attack to phenol faster than benzene? Because phenol contain OH group. OH is an EDG. EDG make the ortho and para position electron rich. So electrophile can easily go there. Where is the answer? Presence of OH group in phenol increase the electron density at ortho and para. Yes. Where more electron density, where nucleophile can attack. Nitration, chlorination, Friedel-Crafts, these all are what? Electrophilic substitution. Question number 76. Picric acid. We know what is picric acid here? When phenol react with the concentrated HNO3, we get 2,4,6-trinitrophenol is called what? Picric acid, yellow precipitate. What is picric acid? 2,4,6-trinitrophenol is called picric acid. So 2,4,6-trinitrophenol is picric acid. Remember its color also, yellow precipitate. Ready? Next one, the major product obtained on interaction of phenol with the sodium hydroxide and carbon dioxide. Do you remember this reaction? Phenol when react with the aqueous NaOH, first what we get? Sodium phenoxide, that's ONA. Sodium phenoxide when treated with carbon dioxide and followed by hydrolysis, what you get here? Salicylic acid. Salicylic acid, this is our Kolb's reaction. So what is the product here? Salicylic acid. 78. In the following reaction, what is this X and Y? Come on dear, what is this X reaction? Phenol react with the bromine in CS2. Bromine and CS2 mean mild bromination. What you get dear? You get orthobromophenol and parabromophenols. Ready? But bromine water, if you are using, you will get 2,4,6-tribromophenol also. Okay, what is the other reaction? What is the other side? Phenol reacting with the chloroform, NaOH and HCl. What is that? Salicylaldehyde. That is our Reamer-Tiemann reaction. So X is ortho and para bromophenol. Y is salicylaldehyde. Option B. Next one. Identify the final product. Ready? We are ready to answer anything. Phenol when treated with zinc. What you get, dear? Benzene. Right? Benzene, what is this? Friedel-Crafts acylation. Which group come to benzene? Benzene with a COCH3. What do you call benzene with a COCH3, dear? Acetophenone. Phenol when react with the zinc, we get benzene. Benzene on Friedel-Crafts acylation, we get acetophenone. Question number 80. Benzoquinone. How many of you remember the product benzoquinone? Benzoquinone is this one. It's a diketone. Benzoquinone, how we prepared from phenol? How many of you remember what is the oxidizing agent? We are using Na2Cr2O7 with H2SO4, chromic acid or sodium dichromate. So dear, phenol when treated with Na2Cr2O7, it's an oxidizing agent converted to benzoquinone. So reagent is what? Option A. Phenol, consider the following reaction. What is the product final? Phenol when treated with zinc, already we discussed, we get benzene. Benzene on, what is this? Friedel-Crafts alkylation, you will get toluene, right? What happened? Toluene when treated with the alkaline. Dear, alkaline KMNO4, acidified KMNO4 are strong oxidizing agent. The alkyl completely converted to what? Acid. So what is a benzene with acid? We call benzoic acid. Question 82. Methyl alcohol. What is methyl alcohol? Methanol, right? CH3OH. Is industrially, we studied wood spirit and all. How methanol is preparing industrially, carbon monoxide react with the 2H2, we get methanol. It is very important to know the catalyst and all. Zinc oxide and Cr2O3 is the catalyst. Around 200 to 300 atm pressure and 573 to 673 Kelvin temperature all are there. 2000 to 3000 Kelvin, 573 Kelvin to 673 Kelvin. High temperature, high pressure. Carbon monoxide react with the 2H2, you get methanol. So answer is which one? CO and H2. The enzyme which can catalyze the conversion of glucose to ethanol. So methanol preparation we study now. What about ethanol? Let me just tell you the theory. What do you know what is C12H22O11? Sucrose. We know sucrose on hydrolysis we will get one glucose and one fructose with the help of an enzyme called invertase. Invertase converts sucrose into glucose and fructose. I am taking this glucose, what is glucose? C6H12O6. So the glucose will convert it into ethanol and the carbon dioxide by the help of an enzyme called zymase. That they are asking here. The enzyme which can catalyze to convert glucose to ethanol, that is what? Zymase. Now, ether is obtained from ethyl alcohol in presence of H2SO4 at 413 Kelvin. Ethers. When alcohol heated with acid at 443 Kelvin, it is dehydration. At 413 Kelvin forms ether. Next, ether are prepared by the reaction of sodium alkoxide and alkyl halide. That is our Williamson ether synthesis. Which of the following reagents should be taken prepare to this one? So, what do you want? Methyl and tert-butyl. Methyl tert-butyl ether if you want to prepare. If you want to prepare this ether, which is the best suitable reagent? Dear, it's very simple. The bigger alkyl part should be sodium alkoxide and the small part should be the haloalkane part. That means I'm taking that methyl chloride with sodium tert-butoxide. Sodium tert-butoxide. This is the best reagent to convert. What is Williamson? When a haloalkane react with the sodium alkoxide, we get ether, right? So this haloalkane should be smaller group. Sodium alkoxide should be bigger one. Then easily the NaCl you can cut and you can get the ether. What happens if it is opposite? What happened that bigger in haloalkane, smaller in sodium alkoxide? Dear, if sodium alkoxide part is small, it acts as a base, strong base. Then beta elimination happen instead of Williamson. So if you want to get Williamson ether process, haloalkane keep it small, sodium alkoxide is big. So where is the answer here? Br, here chlorine I used, Br can be used. Okay, Br is the question. So Br use it. So CH3Br and NaOCS, right? Option B. Next one. Which of the following are the products shown by the reaction of methoxyethane with HI? What is methoxyethane? CH3OCH2CH3. With what? HI. Again, ether bond breaking. Which bond you break, whether left or right of ether? Dear, if on ether primary group, small group when comes, follow the order SN2. What is SN2 mechanism? Break the less crowded CO bond. Where is the less crowded part? That you break it. Which is the less crowded part? Here you break. So oxygen minus CH3 plus. So you get to the CH3 iodine attack plus to the O minus, who will attack? O minus H will attack. So you'll get methyl iodide and ethanol. Where is methyl iodide and ethanol? Option D. So left and right if you have. So this is the theory. I'll give a short method all of you immediately. On how to break ether. There are three cases, okay? Case number 1. If you have left and right, primary, or primary, secondary, or secondary. If this kind of group when comes, follow SN2 mechanism, break the less crowded CO bond. Where is less crowded part? That you break. Second condition, where you have a tertiary with the primary, tertiary with the secondary and all, it follow SN1 mechanism, break the tertiary part always. And one more case is there in aromatic ether. In aromatic ether, for example, anisole and all, this is the condition. After the breaking, you should get phenoxide ion. After the breaking, we should get phenoxide ion. Just by applying this one, check it other question. See, this is the question. In the reaction, what is this anisole? Anisole when react with HI. HI mean HBr, H plus and Br. Where you break. This is an aromatic ether. So the condition after the breaking, you should get phenoxide. So I will break here. Then only I will get phenoxide. And this always oxygen negative, carbon positive. To the negative, who will attack? H plus will attack. So what is the product here? You get phenol and CH3Br, right? Where is the answer? Phenol and CH3Br, option D. Next one, the ether that undergo electrophilic substitution reaction is, their electrophilic substitution is happening aromatic compound, benzene compound. So is it contain benzene? No. Option B. What is this? Anisole. Right? Electrophilic substitution happen on aromatic compound. These all are aliphatic. Right? That's simple. 89. Anisole. What is anisole? Benzene with the OCH3. Alright? Anisole is what? Benzene with the OCH3. Anisole on reaction with the chloromethane. What is chloromethane? CH3Cl in presence of anhydrous. What is this reaction? Friedel-Crafts alkylation. So Friedel-Crafts alkylation means which group comes? CH3 will come. Where we can place it all? Where we can place it here? Anisole is a ortho-para directing group. So you will get ortho-methyl anisole and para-methyl anisole. Ready? So question, or anisole on treated with this compound, ortho-methyl anisole and para-methyl anisole are formed. Para-methyl anisole and para no, ortho-methyl anisole para no, ortho-methyl anisole and para-methyl anisole. First answer is wrong, right? Because this is given ortho-methyl anisole and para-methoxy. Carefully read the question, okay? So answer is what? Option C, ortho-methyl anisole and para-methyl anisole. Here they mention para-methoxy. Careful. Anisole is an ortho-para directing group. On the Friedel-Crafts reaction, you get ortho-methyl and para-methyl anisole. Question number 90. Dehydration of alcohol. Already discussed that. Dehydration, eliminations basically follow SN1 reaction because carbocation stability is the factor. So dehydration of alcohol is an example of, here they're asking dehydration is an example of which one, dear? Elimination reaction, right? Elimination, dehydration, removal of water. Next one, the alcohol which does not react with the Lucas reagent. Tertiary alcohol immediately react. Secondary alcohol, after 5 minutes they give turbidity. Primary alcohol is the one not reacting at a normal temperature. So which is a primary alcohol? N-butanol. What is isobutyl, dear? This is what isobutyl, okay? This is isobutyl alcohol, and N-butyl alcohol mean normal butyl alcohol. Tert-butyl alcohol you already know, right? Tert-butyl alcohol, tertiary. And what is sec-butyl? Sec-butyl means this one. This is what? Sec-butyl alcohol. Alright. Generally, primary alcohol do not, the normal alcohols do not undergo Lucas reaction faster. Phenol react with a bromine in CS2. We discussed the phenol when react with the bromine water, it give you 2,4,6-tribromophenol. But bromine in CS2 is a mild bromination. You will get orthobromophenol and parabromophenol. You will get ortho and parabromophenol. 93. What is aspirin? The medicine which is using, right? What is aspirin, dear? We studied when phenol, what is phenol and what is COH here? Salicylic acid. When salicylic acid react with acetic anhydride, what is this compound called? Acetic anhydride. What do you get? What do you get? You get OH and OCOCH3. This is called acetyl salicylic acid, called aspirin. Salicylic acid when react with acetic anhydride, you will get acetyl salicylic acid. This is called our aspirin. So what is aspirin? Acetyl salicylic acid. 94. Identify the catalyst in the hydration of alkene to produce alcohol. You know, alkene when react with the water in presence of an acid, you will get alcohol. This is called acid catalyzed hydration. What is the catalyst we are using? An acid. What is an acid? HCl. The first step of the mechanism, you may study the 3 mechanisms in this chapter: alkene to alcohol, alcohol to alkene, alcohol to ether. The first step of the mechanism of conversion of ethanol to ethoxyethane. There are 3 steps actually. Ethanol. What is the first step you remember? How many of you remember the first step, dear? You will take the alcohol. You know, we will treat acid with what temperature? 413, right? What is the first step in this one? The alcohol that get protonated. They will take the proton to ethanol. So what do you get? CH3, CH2, OH, lone pair hydrogen plus. So H plus addition, what we call protonation. So protonation is happening on ethanol. So protonation of ethanol. First step, please study all of you. First step in this mechanism, protonation. And from the textbook you can able to understand. Second step is what? The removal of water. Third step is what? Deprotonation. The question number 96. What happens when an aldehyde is treated with a lithium aluminium hydride? Lithium aluminium hydride is a reducing agent. So aldehyde on reduction, what you get? Primary alcohol. Primary alcohol is formed. Now, primary alcohol is formed. Next one, which of the following aldehyde can produce primary alcohol when treated with a Grignard reagent? We discussed that. Methanol. Methanol or formaldehyde, when react with the Grignard, we will get a primary alcohol. That's what? Methanol. What about other aldehyde? Secondary alcohol. What about ketone? Tertiary alcohol. Next, what is the final major product in Reimer-Tiemann? Reimer-Tiemann give you salicyl aldehyde. Salicyl aldehyde. Which salicyl aldehyde? What is salicyl aldehyde? Actually, we are writing OH and CHO. So CHO is the main group. So this is ortho, right? This is the ortho position. So ortho salicyl aldehyde. Next one. Aspirin is already we discussed. Aspirin is produced from the reaction between salicylic acid with what? Acetic anhydride, right? Acetic anhydride. Last question, dear. To get carboxylic acid directly from alcohol, we studied primary alcohol. If you want to directly convert into carboxylic acid, we need a strongest oxidizing agent. That is what? Acidified KMNO4. Alkaline acidified, where acidified KMNO4 is the strongest one. So these are the 100 MCQ from the chapter alcohols, phenols and ethers.